Welcome to School of Computing. In this session, we try to understand linked list data structure. Linked list is a linear data structure which stores information in the form of nodes. Each node comprises of data and address of the next node. Node is basically created using a structure type. So linked list is a very popular and very important data structure, and in our introductory sessions we have discussed the various real-time applications of linked list. So you can refer the previous session of introduction to data structures, in which we have discussed various real-time applications of linked list data structure. So what a node contains? Node has only two components. One is data inside the node and an address. Data inside the node can be anything. It can be an integer type, it can be any primitive data type like int, float, char, long, or it can be any other user defined type as well. And the address component in the node is a pointer of node type itself, which is capable of pointing to another node. So if we have a node pointer as one of the member in the structure, such structures are called as self-referential structures, because one of the member is a pointer pointing to the same structure. So a pointer capable of pointing to the same node, then we say such structures are self-referential structures. Typically, a node will look like this. So generally, a node will have two components, data and address of the next node. If you observe, this is an example where the blue color content is the data and something which is in green is the address of the next node. So in my first example, you can see there are three nodes and the data inside these three nodes is 10, 123H. H actually represents hexadecimal number. It means it's an address. 123 is address of second node and the data inside second node is 20. Address of third node is present in second node's pointer, and I'm able to reach out to the third node, and when I see null, it means it is end of the list. So null helps me in identifying the end of the list, and in order to know where is the first element in the list, we will use a special pointer. Again, it is also a node type pointer called as head. It will be pointing to the first node. And if I have two pointers, see the second example, you will find a data and you have two addresses, two components in green color. Means if you observe in the first linked list, the arrow is unidirectional, right? So it's a single linked list. The first one is a single linked list. Means from first element I can reach out to second, from second I can go to third, but from third to second there is no address or there is no way out. From second to one, it's not bidirectional. So such linked lists are called as single linked list. And the next one is called as a double linked list, in which we have two address components. Means the total number of elements are three, data and two pointers. As the name itself suggests, PREV is previous, next means pointing to the next node. So it's bidirectional. I can move in both ways inside the list. I can come to previous node and I can go to next node. Such list is called as double linked list. Friends, for example, If I replace this null with 123H, what do you mean by this? What do you mean by this? It means I am able to connect from the last node to the first node again. So it forms a circle. It forms a circle. When the last node is pointing again to the first node, it forms a loop. Such linked list is called as circular linked list. So what do you mean by circular linked list? The list whose last node contains the address of the first node, then it's called as circular linked list. Let's move on. So how to create a node? Typically, a node will look like this. So friends, I am not creating a node. Please try to understand. We are just creating a data type called as node. We all know structures are used to create user-defined data type. Why I am creating a user-defined data type? Because I need to store data and address together. I need to store data and address together as a single unit. So how can I store data and address together as a single unit? With existing data types, it's not possible. For example, if I take integer, can I store both data and address? No. Similarly, you take any primitive data type, built-in data type, we don't have a data type where we can store two different components, one is data and one is address. Since the built-in data types are not suitable for my requirement, I am creating my own data type called as node. So struct node int data, this is my first component which is an integer data. It can be anything, by the way. Then please observe this one, next, star next. It's a pointer of what type? Node type, right? So whatever you are seeing here, I can create that kind of data type using structure. Now since the pointer is pointing to the same node again, means it is capable of referring to the same structure. That's the reason if a structure contains a pointer of same type, node type, then the structures are called as self-referential structures, right? So friends, I hope you got a fair understanding of what is a list and what are the three types of list. Let us try to understand in detail about the various operations that can be done on the list. So typically a node will look like this. So this is a node. A node has two components, data and address. So friends, for example, let us assume the data here is 10 and the address component, let me say this is 123H. So friends, this is address. And for example, I have my second node, right? Or else the second node is not yet created. When nothing is there, when we have created our first node, we take help of a pointer called as head. So what is head? Head is a pointer of what type? Structure type, node type pointer, which is actually initialized to null. So when first time a node gets created, when nothing is there, no node is existing, then head will be null. But first time when a node gets created, head will be pointing to the first node. Friends, always head should point to the first node. Now, for example, I wanted to insert one more node. So second node I am inserting. Let us say the data is 20. Whenever we insert a new node, actually what we do is we will write data in the data component and we will write null in the address component. Whenever a new node gets created, this is what actually I am supposed to do. Even here, when a new node is created, it should be null initially. Only when I connect the first node with the second node, then I'll fill this with the address. So initially, this 123H was actually null. When I connect my first and second node, then 123H, the address of second node will come here. So for example, I'll continue to create one more node. So for example, there are two nodes in the linked list. Now I wanted to create a new node. So whenever I create a new node, whenever a new node gets created, there will be a pointer pointing to the new node. So always new nodes are pointed. Always new node, whether it is first, second or third, always new node is a pointer pointing to the new node. And imagine data inside the new node is 30. As usual, since this is the new node, the address will be null. Now what is the task? I need to connect the second node with the third node. Then only it will be a proper linked list, because before third node was inserted, there were only two elements and hence there was a null in the second node because second node is the last one. Now what I need to do, if I need to connect second and third one, I should replace null with the address of new node. So friends, what we will do, we will create a node called as temp, which is also initialized to head. So I will see what is there in the next part of temp. Is it null or not null? It is not null. So again, by looking at this address, I'll move my temp. Now temp will be pointing to the second node. Again, I'll look into the address component of temp. What is there? There is null in it. So I repeat this process of moving temp from first node till I find a null in the next further nodes. When I find a null, it means that is the last node in the existing linked list. Now what I will do is I will replace this null with address of this new node. When I replace null with this address of new node, what will happen? Now this null is replaced with address of new node. So it means second node is now pointing to third node. So friends, it is all updating and modifying pointers. When you are talking about linked list, it is all about pointers. So we need to have clear understanding of basic pointer concept, and if we know how to play with pointers, that's it. Linked list and all other types of linked lists are very simple to handle. This is about creating a new node. For example, if I wanted to delete a node, what need to be done? For example, I want to delete this particular node. What need to be done? So please observe, what we have to do is we have to, so this is my first node, 10, then 123H is the address. So this is my first node. Now if I wanted to perform delete operation, what I need to do, I need to replace 123H is address of second node. So what we have to do is we have to replace this 123 with address of third node. The moment I can replace the address with third node, now what will happen? Let us assume the address of third node is 456 for example. Then what I have done, I have connected 193. So it's like bypassing. When I wanted to remove second node, I connect first and third. The moment I connect 1 and 3, I have deleted second node. So we also need to have good understanding of malloc, because malloc does memory allocation for me, and we also need to understand a function called as free, which will help in deleting or releasing the unwanted memory. So whenever I create a node, I take help of malloc, and whenever I wanted to release the memory, I'll take help of free function. So friends, this is about the various operations of a linked list. I hope you have understood basic things about linked list. So quickly I summarize. Linked list is a linear data structure. It is implemented using self-referential structures. There are three types of list: single, double, and circular list. So friends, in the next session, we try to implement linked list program using C. I hope before we implement the linked list program, I hope the fundamental concept of linked list is clear to everyone. Thank you.